equilibrium. Particle of mass 2.4 kg, equilibrium, 2 strings. One is attached to point A and B, angles 35 degrees, 40 degrees. Find the tension in each of the 2 strings. So we have tension A, tension B. So for tension A, we can split this into TA sine, TA cos because of this triangle. So if you look at this triangle, there's a right angle here. So just call this length y, this length x, using sine. Sine is opposite over hypotenuse. We have this from the sine, and from the cos, adjacent over hypotenuse, we have this from the cos. If we multiply both sides by TA, we have y equals TA sine. So this vertical length is TA sine, so this is TA sine, and the x is TA cos, so the horizontal component is TA cos, and the diagonal in this triangle is TB, tension B. We draw this triangle. Again, we label them something, and then we use sine and cos. We can split this TB into TB sine and TB cos. And then now we use sigma F equals 0. In the horizontal direction, the forces to the left equals forces to the right. To the left, we have only TA cos. To the right, we have only TB cos 40. And from upwards equals downwards. Upwards, we have 2 forces, TA sine and TB sine. Downwards, we have 24 because this is the mass. The weight force is mass times g. So 2.4 times 10, that's 24. So now we have 2 equations in 2 variables. We can solve them by substitution or elimination. So here we can just substitute. We divide both sides by cos 35, so we have TB cos over cos, and we replace the TA here with TB cos. With this, we replace the TA. So now everything's in TB. We can factor out the TB, and then we divide both sides by the brackets and use a calculator. We get the TB value. To find the TA, well, since we know TB already, just use the answer button from the calculator or the store function. Or if you want to use this value, don't use 3SF, use at least 4 or 5 SF so you don't lose accuracy. If we use only 3SF, the final answer might be wrong because it might be slightly inaccurate in 3SF. Okay, so do not round off unless it's the final answer. So this is the final answer, tension in A, tension in B. Alright, I'll see you again next time.